Hello friends, in today's question, the magnitude of torque on a particle of mass 1 kg is 2.5 Newton meter about the origin. If the force acting on it is 1 Newton and the distance of the particle from the origin is 5 meter, then the angle between the force and the position vector is. So we have to find out the angle between the force and the position vector. Okay. So we are given that torque acting on a particle. So we can write the formula for that torque. Tau is your R cross F, where R is the position vector of the particle and F is the applied force, and this can be written as RF sine of theta, where theta is the angle between R and F. So from here we are supposed to find out angle. Then we can write this as sine of theta is equal to tau upon RF. Torque is given as 2.5 and the distance is given as 5 meters and the applied force is 1 Newton. This comes as 0.5. Therefore theta we are supposed to find in the radians. So theta will be equal to sine inverse of 0.5, or we can say that theta will be equal to pi by 6 radians. So this is the angle between the applied force and position vector. From here we can say the option number D is the correct option. Option D is correct. Now let us solve another question. It was also in 2019 mains. It is given that a slab is subjected to two forces F1 and F2 of the same magnitude F as shown in figure. Force F2 is in xy plane while force F1 acts along z-axis at a point 2i plus 3j. I and j are unit vectors. The moment of these forces about point O will be. So there are two forces F1 and F2. F2 is acting on xy plane and F1 is along z-axis. So we have to find out the total moment. Moment. Okay. So we can say that the unit vector along y is j, along x will be I, and along z it will be k unit vector. And it is given that the position vector of force F1, so this is a position vector of force F1, and it is given as 2i plus 3j, and force F2 is acting along y-axis at an angle of, not along y-axis but an angle of 30 degree with the y-axis. And we can find out the coordinate of F2 also. So this is 6 meter. So this distance will be also 6 meter. So we can say the coordinate for F2 will be our 0i plus 6j. This will be the coordinate of F2. And this F2 can be divided into two components. It is acting in this way This is our F2, making an angle of 30 degree, and this is other part. So we can say this will be equal to F2 sine of 30, and this will be F2 cos of 30. And in terms of unit vector, F2 will be having a unit vector k, and F2 sine theta is going to have unit vector k, and F2 cos theta is going to have a unit vector of minus j. So we are given that F1 is acting along z-axis, direction is along z-axis, therefore we can say that F1 is equal to F k unit vector, and its position vector, let us suppose is R1, will be given as 2i plus 3j, and similarly one second, I think there is some mistake on my part. Yeah, let me redraw it again. So we can say that F2 force is going to have two components. One will be our F sine of 30, and with a unit vector of minus of I, and another vector will be plus F cos of 30, and it will be minus of j. Okay, sorry, I do it wrong. So it is in xy plane. So this is our F2, and this is angle of 30 degree. So this will be F2 cos of 30, and unit vector is minus of j, and we are going to have this as F2 sine of 30, and its unit vector will be minus of I. Sorry for that. And if we substitute the values, sine 30 and cos 30, we can say our F2 will be equal to F upon 2 minus of I plus F square root of 3 divided by 2, and it will be minus of j. And its unit vector, its position vector, that is R2, can be given as 0i plus 6j. So first of all, we are going to find out the torque because of F1, then we are going to find out the torque because of F2. You can say torque due to force F1, torque due to force F1, let us call that as torque F1. It will be cross product of position vector R1 and F1. R1 we already know is 2i plus 3j, cross product with F k unit vector. So this comes as 2f, and we have I cross k plus 3f and j cross k. Therefore we get tau, because torque because of force vector F1 will be equal to 2f minus of j plus 3f and I unit vector. So we found out torque because of force F1. Similarly, we are going to find out torque because of force F2. Torque due to force F2, and we have let us suppose is given as tau f2, which will be equal to position vector r2 and cross product with f2. Position vector r2 is our 0i plus 6j, cross product f2 is our f2 upon minus of I plus f square root of 3 divided by 2 minus of j. Therefore, we can write this as tau f2 will be equal to, this will be 6 multiplied by f by 2 into j cross minus of I, and this will be plus 6 square root of 3 divided by 2 and multiply by f, and we are going to have it as j cross minus of j. So we get this as tau f2 will be equal to, this goes by 3 and this comes as 3f and k unit vector, and this will be 0. So we got the tau f2, that is torque because of force f2. Therefore we can say net torque will be, let us suppose again as tau net. This will be equal to torque because of f1 plus torque because of f2. Now simply substituting the values, we get tau net, tau f1 we found out is equal to is 3fi, and this will be minus 2fj and plus 3fk. Taking f as common, you can say tau net is equal to 3i minus 2j plus 3k times f. So this is the moment of the forces about point A, O. This is the moment of forces F1 and F2 about point O. Therefore, if we check the option available to us, we can say 3i plus minus 2j plus 3k. 3i, yeah, option number B is the correct option. Option B is the correct one. So we can say that option B is correct. So this completes the two questions. Okay. Thank you.